Hello, 7th graders. This is Miss White, and today we're doing Lesson 14 problem set. We're going to go ahead and get started with number 2. So number 2 says, indicate whether the following are random samples from the given population and explain why or why not. A, the population of all the students in the school. The sample includes every 5th student in the hall outside of class.
No, not everyone would be in our hall before class. In our hall, we only have the white team. So the gold team and the purple team would not have a chance to be chosen. So let's go ahead and as our response, we are going to write no. Not everyone in the school would be in our hallway before class. All right, let's move on to B. The population. Students in your class. The sample consists of students who have the letter S in their last names. So look around at your class. If you know everybody's last name in your class, try to figure out who doesn't have an S in their last name. Now, this sample response would not be at random because the students who do not have a letter S in their last names would not have a chance to be chosen. So we're going to go ahead and write no for this one as well. So students without an S in their name would not be able to be chosen. And if I was a student, I want to be able to get chosen because my last name is White. All right, let's look at C. Students in your class. So this is the population now. The sample is selected by putting their names in a hat and drawing the sample from the hat. Well, let's look around at your class. If everybody put their names in a hat, would everybody have a chance to be drawn from that hat? Well, the answer is yes. So everyone would have the same chance to be chosen. All right. D. The population is the people in your neighborhood. The sample includes those outside in the neighborhood at 6 p.m. So for our sample response, is everybody usually out of their houses, outside, maybe playing, barbecuing, running, maybe taking those dogs outside at 6 p.m.? Well, the answer would be no, because people who are not in a neighborhood at that time have no chance of being selected. So maybe you and your family went to a baseball game, or somebody had to go to an appointment at 6 p.m. We don't know. So the chance of that happening would be no. And again, we want to say that because people who are not in the neighborhood at that time have no chance of being selected. All right, and then our last one for number 2. The population. Everyone in a room. The sample is selected by having everyone toss a coin, and those that result in heads are the sample. And that sample response would be yes, because everyone would have the same chance to be chosen. That being said, everyone would flip the coin, and then everybody still has the same chance of getting heads. All right, go ahead and write this down if you haven't already. Then we will start number 3. All right, before we start number 3, I just want to make you aware that there is a lot of writing to answer these problems. I am going to try my best to give you ideas on where to write this. I'm literally thinking maybe we'll write the answer to A here and the answer to B here, and that we just need to label it. I totally understand that this packet does not give us enough room, and I apologize about that. All right, number 3. Consider the 2 sample distributions of the number of letters in randomly selected words shown below. Now A, describe each distribution using statistical terms as much as possible. Well, the top distribution seems to have both a medium and a balance point, or mean, at 3. With a minimum, so of 1 in a word, and a maximum of 7 letters in a word. So most of the words in the sample were about 2 to 4 letters long, and the bottom distribution seems to be more skewed, with the medium being about 4 letters, and the smallest number of letters was 2, and the largest was 10. But most of the letters in the sample were between 2 and 5. So for A, for sample 1, I guess we'll go ahead and say that the median and balance point, also our mean is about 3. All right, and then our maximum was 7, and our minimum is 1. Okay, then we'll go ahead and do the same thing for sample 2. So for sample 2, the median looks to be about 4 letters, and the maximum is 10, and the minimum is 2. So B, do you think the 2 samples came from the same poem? Why or why not? So now we're looking at these words and thinking, okay, if these were both a poem, would they be a part of the same poem? Maybe this is the first part of the poem, and maybe this is the second part of the poem. And these samples could have came from the same poem, but we notice that the distribution seemed very different. And we see that because the way that it is shaped and measured in the center. So it's likely that they were from both different poems. So they seem to be from 2 different poems. Because the distribution of the letters are different. All right, once you're done writing down number 3, we're going to do number 4. So what questions about samples and populations might you want to ask if you saw the following headlines in a newspaper? And even today, I mean, newspapers are really not something that I'm not gonna lie, I read. I don't really read a newspaper, but I read like social media feeds, and I know all the time we see different articles and different headlines. So let's kind of think about it more in that direction. So we see a headline that says peach pop is the top flavor according to 8 out of 10 people. Well, what's something that you would ask about that data? Would you possibly ask, how were these people selected? How many people were surveyed? And what were the choices they were given? And then how many people didn't like it? So when we think about these headlines, we need to think about, what are they asking? Maybe they literally only asked 10 people. Because when we think 8 out of 10 people, we want to believe that they asked more than 10 people and that they're just simplifying it down for us a bit. But maybe it's not the case. So asking how were the people selected and how many people were surveyed are great questions to ask. We'll go ahead and write those down. All right. Now let's look at B. Candidate X looks like a winner. 10 out of 12 people indicate that they will vote for candidate X. Okay, so this sounds more like a voting type of poll. Again, what are some questions that we want to know? Maybe, how was the sample chosen? And I think that's a really good indication, because who knows where they got this data? Maybe the sample was chosen at that candidate's event rally. Or were the people selected at random? Were they just on the street? Are they friends of that candidate? We don't know. These are the kind of questions that we want to ask ourselves as we are making a decision on what we believe or what might be most popular. So for this one, I'm going to write down, how was the sample chosen? If you have a better question, though, go ahead and use yours. Okay. C, students overworked. Over half of 400 people surveyed think students spend too many hours on homework. Well, with this school year, I'm sure you guys can probably agree with that, right? And it says that they surveyed 400 people, which is pretty neat. Now we know how many people were surveyed. And it says over half of 400 people. Well, that's kind of skeptical, because we don't even know what that number of people, the exact number of people who said that students get too many hours of homework. So maybe my question would be, first of all, who were surveyed? Were parents surveyed? Were students surveyed? Were dogs surveyed? Probably not dogs, but you guys get what I mean. And then how were these people selected? Did they maybe do teachers? Did they do your parents? Again, they could have done students. Or maybe they were random people at the mall. We don't know. And was the survey given to students in a school? Because let's be honest, this year, I'm sure most of you would have put in your survey that you had too much homework, right? Probably too much math homework too. So that would make a good indication on the number and the outcome. So here I'm going to use who was surveyed and how were they selected. If you have a better question, go ahead and write it down. Okay. And then D, action/adventure was selected as the favorite movie type by an overwhelming 75% of those who surveyed. Okay. Again, I'm going to let you think about what type of question you would ask in order to make this statement more accurate to you. Go ahead and pause the video, write down your question, and then we'll move on to the next problem set. All right, now we're on to problem set 15. Go ahead, and we are actually going to start with number 2. So, given the following sample of scores on a physical fitness test, from which of the following populations might the sample have been chosen? Explain your reasoning. So first, we need to look at the sample down here. Okay, whoa, I didn't mean to do that. I don't know what I'm doing. Hold on. Okay, now I know what I'm doing. Okay, so we have the sample down here, and down here is indicating where we took our samples. Where we have grade 5, grade 6, grade 8, and grade 7, this is data that's been taken. But down here is the samples from where this data has been taken. So these sample values were not really in grade 5 or grade 7 because I don't see a lot happening for them down here. Now we may have gotten a couple from grade 5, but that is about it. And so because of that, we know it could have either come from the 6th grade or the 7th grade because it looks like there's more heavier indications of data there. So the sample distribution looks skewed like 6th grade, but the sample size is too small to be sure. And notice that there's not, a lot of samples that were taken compared to the amount of data that was taken as well. So now we know that the sample values were not taken from grade 5 or 7. And that it could have been heavily taken from grades 6 or 8. But remember that the sample distribution is skewed more towards the 6th grade, but the sample size is too small to be sure. Number 3, consider the distribution below. Here are some population values. What would you expect the distribution of a random sample of size 10 from this population to look like? Well, the samples will probably have at least 1 or 2 elements between 80 and 90 and might go as low as 60. But the samples will vary a lot, so it's very hard to tell. So for B, it says the random samples of different sizes that were selected from the population in part A are displayed below. So how did our answer from part A compare to the samples of size 10? Okay, so here is our sample size, and we can look at size 10. Well, we can say that our description was pretty close. We got more values between 80 and 90 than we did below 80.
All right, now so C. Why is it reasonable to think that these samples could have come from the above population? Well, each sampled is centered about where the population is centered. Okay, so we see down here that we have less data, and then up here, also in our population values and our sample data, we definitely have more data in our larger values. So the spread of each sample looks like the spread of each population. And finally, D. What do you observe about the sample distribution as the sample size increases? Well, as the sample size increases, the sample distribution more closely resembles the population distribution. So as we look here, we can see that again from C, we said that both spreads kind of look the same. Obviously, our sample data is going to look and be more simplified. But again, as the sample size increases, the sample distribution more closely resembles the population distribution. All right, and I'm barely running out of room here. Population distribution. We're just going to do this. All right.